Hello, everyone. This is the group that we're gonna talk about the structured charts. I'm Juan Alvarez, and I'm with here with my classmate Jose Paredes, and here we're gonna start.
A structure chart, when it comes to software development, is a breakdown of a system into functions with each performing one specific task. These are called modules. This chart describes the flow of data and control between them. The overall chart shows the relationships between the modules and displays the flow and transformation of data between them. If this sounds like a data flow diagram or a control flow diagram, then that is what the structured chart is like. It is said by some to be a chart derived from both of these diagrams to show the relationships between the modules. One thing that should be noted is that structure charts are not used to display procedural logic. That is the job of flowcharts and pseudocode. Now that we know what a structure chart is, let's look at the symbols used in making a structure chart. The first symbol, being a black box, represents a module, the basic unit of the chart. There are three types of modules. The first is the control module, in which the most important detail to note is that it has more than one submodules that are connected to it. The third module is called a library module that differs with having two lines inside the box. This module is a reusable module that can be called by any other module. A control module that has a diamond at its base indicates that it will call submodules based on conditions. The arrow connecting from one module and pointing to another means that the module is calling the other module that is being pointed at. A loop arrow at the base of a control module indicates that after the execution of a submodule, it will return to control module and execute again. Now, arrows with empty circle tails indicate the flow of data, while filled circle tails on arrows indicate the transfer of control information. In the case of structure charts, it's usually error or end of condition information. Lastly, a round box is the indication of storage or data in rest. There are also other symbols that people use when making structure charts, but that depends from person to person, as there are some extras, such as where when an arrow is like pointing toward the middle of a module to state that control is being put in the middle of that function, and many others. But for the most part, these are the basic symbols used when making a structure chart. So, in order to demonstrate this chart, I will make a simple one using the purchase tracker feature as the base. The control module wouldn't be the purchase tracker since it is not a single function. It will be some sort of UI, but for the sake of demonstration, we'll just call it purchase tracker for now. The way that the purchase tracker works is that it gives the option to either use the receipt scanner or enter the fields of a purchase manually. So that is why we have them both as submodules to the purchase tracker. We see that there is a diamond on the purchase tracker module. That is to indicate that it's up to the user to decide which route to take. We also see that a photo is being sent to the receipt scanner with the empty circle arrow. The receipt scanner requires a photo to be used. There is also a filled circle arrow pointing back at purchase tracker to indicate there was an error or the user decides to cancel and go back. Then, after receipt scanner is done, it then must first use the confirm module to get the OK on whether the user wants to use the info found to be added to the budget. Then the confirm module will send a filled circle arrow back to receipt scanner to let it know the process is canceled or good to go. Manual entry does not get a confirmed submodule because it was not specified in the SRS. When either module is done.
Okay, perfect. So with all this, we gotta understand as well what are the advantages and disadvantages to use a structured chart. So we're gonna start with the advantages. The advantages are that a structured chart. It's really easy to understand the relationship of different models inside a program. So it's really correlated basically, and you can easily follow how everything's gonna follow throughout the program and the models of the program. Then The submodels as well help define the functions of a bigger model with them. As well as for us programmers, it will provide a simple to read interface. So I can just say that, as programmers, we always like, well, as much as possible to have something that really can be easy to read, so we can either start working on it, or if it was already created, just to, follow along and understand what's the purpose of the program that it's in existence that we're going to be working with. As well, we have disadvantages to all this. There are very few as well. Well, sometimes it's really hard to determine the difficulty of each level. It's time consuming to create. It will take a lot of time to come out with a way to have a structured chart really well done. And changes in design can be, and because of it, changes in design can really become difficult to, like, it could be difficult to redesign if you want to make a change. Uh, Also, we have recommendations of how to use it. Uh, the use of structured charts we can use structured charts to describe the functions and subfunctions of each model, and it's a great way to show the relationship between different models inside a program. So basically, I think the advantages overpass the disadvantages, because the final product per se could be like really gratificating in a way, saying, okay, this is easy to read, it's understandable, even though it's going to take a lot of time. But it's easier to comprehend and simple to read, which is basically, at least for me, a dream whenever I'm working with a piece of software program. So that will be our presentation for this topic, and I hope you liked it, and we're hoping to also get the test done.